Hi there everyone, welcome back. This is our video for lesson 1.6, solving absolute value inequalities. We've already talked about how to solve absolute value equations, in which we had to set up two equations, one with a positive solution and one with a negative solution. The reason being is because we know that no matter what type of value we put inside of absolute value bars, be it positive or negative, the absolute value measures our distance away from zero on a number line, and therefore distance is always positive, so absolute value bars will always turn our solutions positive. So now we're going to explore how you can solve absolute value inequalities. Picking up where we left off on our guided notes, we're on example number 7. We've got the absolute value of b minus 4 is greater than or equal to 6. So as we have done with absolute value equations, we're going to set up two inequalities in order to solve. The first inequality is not going to be very different from the original. We're just going to be dropping the absolute value bars. So we have b minus 4 is greater than or equal to 6. We're going to make this a compound inequality, so we're going to write or in the middle. And then we're going to have b minus 4. And now we're going to flip our inequality symbol the opposite direction so that it says that it's less than or equal to. And we're going to change our positive 6 to a negative 6. On the left in my first equation, I want to add 4 to both sides so that I get b is greater than or equal to 10. And in my second inequality, I'm going to add 4 to both sides so that I get b is less than or equal to negative 2. As we've also done before, we're going to write our solutions in solution set notation, defining our variable, and then saying that b is less than or equal to negative 2, or b is greater than or equal to positive 10. And of course, as we've done in the previous lesson, we are going to graph our solution set on the number line with closed circles at negative 2 and at positive 10, indicating that both of those values are a part of my solution set. And then we're going to do our shading. So we'll start with our negative 2, and our inequality tells us that b is less than or equal to negative 2. So we'll be shading all values on our number line that are less than negative 2 to the left. Our second inequality indicates that b can also be greater than or equal to 10. So we're going to shade the part of our number line that shows b is greater than 10, which is to the right. In our next example, number 8, we've got the absolute value of 3x plus 4 is less than 10. For this inequality, when we write our compound equation, we're going to start off writing negative 10 on the left side of what will be our compound inequality, followed by the less than symbol, and then our part that's in parentheses, which is 3x plus 4. So we've got our 3x plus 4 in the middle, and finally we're going to keep our positive 10 on the right. So the reason why we've set up our absolute value inequality in this manner is because we began with the less than symbol. So anytime you see that less than symbol or the less than equal to symbol, you can feel free to write yourself a compound inequality with the negative solution, which is going to be negative 10 on the left, and our positive solution, which in this case is positive 10, on the right. So now we're going to solve this as a compound inequality, and at this point you should pause the video to solve the rest of this equation and graph it by yourself. So at this point you should have paused your video to solve number 8 on your own. Here's how your solution should look. Negative 4.6 repeating is less than x, is less than 2. You should have open circles at both negative 4.6 and at positive 2. And this is an and compound inequality, so we should be shading in between our two values for our solution region. Last thing I'd like to have you do is stop the video now and see if you can solve number 9 on your own. We will check everyone's solution tomorrow in class.